So let's quickly read this limit question. Seems a pretty simple one. We have limit x tending to 2, 3 raised to x plus 3 raised to 3 minus x. Okay, so that is 3 raised to 3 by 3 raised to x. See, if you write 3 raised to 3 minus x, that is nothing but what? 3 cube by 3 raised to x, or 27 by 3 raised to x. Perfect. Okay. And then we have 3 raised to minus x by 2 minus 3 raised to 1 minus x, which is nothing but 3 by 3 raised to x. Okay. So in all such cases, can you see that 3 raised to x by 2 is something which is occurring again and again. So 3 raised to x is there, 3 raised to x by 2 is there. It's advisable that you convert this 3 raised to x by 2 by some variable. It will ease out your calculation. So in the examination hall, especially in the mains one, try to simplify your calculation by doing such substitutions. All right, okay. So the key takeaway is that you have to do a substitution to ease out the calculation. Make sure to change the limit. The limit originally is x tending to 2. So you have to do the adjustment if you make a substitution, right? Perfect. Okay, so let's quickly begin with it. So initially I have just written into the most simplified format. So we got 3 power x plus 27 by 3 raised to x minus 12 whole divided by 3 raised to minus x by 2, that is 1 upon 3 raised to x by 2, and minus of 3 by 3 raised to x. Okay, sorted. Now, as I can say that 3 raised to x by 2 was occurring at multiple times, so I'll be assuming this 3 raised to x by 2 as t. But since when x tending to 2, it implies that t will be tending to 3 raised to 2 by 2, which is nothing but 1. Are you getting my point? So, I would say that t will be tending to 1. So, if you are, sorry, not 1, t will be tending to 3 raised to 1. Are you getting my point? I repeat that if x is tending to 2, so t will be tending to 3 raised to 2 by 2, that is 3 raised to 1. Okay, so t is tending to 3 in nutshell. So let's convert the entire question. My entire question got converted as limit t tending to 3 raised to 1 or 3. Then we have this as t square plus 27 by t square minus 12 whole divided by 1 upon t minus 3 by t square. What we have to do? Just simply take up the LCM. There is no other way out. The moment when I take up the LCM, we get this t power 4 plus 27 minus 12t square whole divided by t square completely divided by t minus 3 divided by t square. So this t square got cancelled. Numerator is a very simple expression, so I can factorize it. Let's quickly factorize it if you can. So we have this t power 4 minus 9t square minus 3t square plus 27 whole divided by simply t minus 3. Right, okay, limit symbol has to be there. So limit t tending to 3 in both the cases. Here also I'll plug in my limit symbol, limit t tending to 3. So now, let's, after factorization, my expression modified to limit t tending to 3. This implies that t tending to 3, or this will become equal to limit t tending to 3. We have the factorization as t square minus 3 into t square minus 9 whole divided by t minus 3. Can you see? When t tending to 3, the denominator is going to 0. And because of that only, that indeterminacy of 0 by 0 is coming. See, when t tends to 3, this term in the numerator is going to 0 and this term in the denominator is going to 0. Right? And because of that only, it is creating the form of 0 by 0. That indeterminacy is actually arising here. Right? So for that purpose only, to get rid of that purpose, we have to remove that indeterminacy. And that can happen only when I simplify it. So that is nothing but limit t tending to 3. We get this as t square minus 3. Here we have this as t plus 3 into t minus 3 whole divided by t minus 3. So t minus 3 will get cancelled. Indeterminacy is removed. The one which was making it 0 by 0 form, that case is gone. See, t is tending to 3, right? T is not exactly 3. Since t is tending to 3, so t minus 3 in the numerator and denominator both will be a finite quantity. Finite non-zero, right? It will be a very small, of course, but it will be a finite non-zero quantity. So whatever the amount that I'll have in the numerator, that is in the denominator, so I can surely cancel it, right? To remove the indeterminacy. Now what I'm left with? I'm simply left with limit t tending to 3, t square minus 3 into t plus 3. So when you plug in the value, so when I put t tending to 3, now I can directly put that. So we get this as 9 minus 3 into 3 plus 3, which is 6 into 6 or 36. All right. So my answer to this particular one becomes equal to what? 36. Understood, guys? All right. Okay. So the key takeaway is that if you are coming across many exponential terms, substitute them by a simple format. See, here putting 3 raised to x will not be a good idea, because if you try to put 3 raised to x as t, then 3 raised to x by 2, you have to deal with root t. dealing with in the examination hall, in that pressure that you have to solve many questions, that too very quickly and accurately, I will not suggest you to deal with the irrational powers as much as possible. When it is unavoidable, you have to, but otherwise, you should not at least invite the troubles from your side, right? So try to keep 3 raised to x by 2 as t, not 3 raised to x as t, right? It will expedite your solution and definitely will be having a quick and the correct answer. So my answer to this question becomes equal to what? 36. Understood? Now guys, if you have not revised statistics, then you must have got stuck into this question. So I would suggest you that understood the concept which I'm teaching you in this particular one, so that at least the question which you get from of this sort of, or the concept of variance, it should not be a mistake. And it's a very popular thing, right? It's a very important thing also. That in many of the times we have seen this question being repeating, or not exactly the question, the idea. So if variance of first and natural numbers is 10, so I have first and natural number and then their variance is 10. The variance of first m even natural numbers is 16. Then they're asking for the value of m plus n. So first of all, I have to remember the formula of variance. If you don't remember that, you will be actually not be able to solve it. So I'll first of all give you the formula for variance. So can you see that partial value, partial delta over there, the smaller one, that is called variance. So delta square is equal to sigma xi square by n, where n is the total number of observation, minus sigma xi by n the whole square. So this quantity inside the bracket is nothing but the mean, mu. So you can also call this formula as sigma xi square by n minus mu square. Are you getting my point, what I'm trying to say here? All right. Okay. Which in terms of expectation value, if you want to write it, this is nothing but expectation value of xi square minus expectation value of xi the whole square. So expectation value of xi is nothing but what? Mean, mu. And this is the average. Expectation value is nothing but what? Mean value or average value. So what is that? Xi square. So summation xi square by n. N is the total number of observation. That's how we calculate the average. So all the formulas are equally correct and they more or less mean the same thing, right? Their meaning are exactly the same. So you just have to be comfortable with either of them. You don't know which one might come up in your examination, so be ready for all of them and just refer to the BYJU'S videos. You will be able to find out what exactly how we have generated it, or the other methods, or the discussion associated to it, some more examples even on that. All right, so this is what the formula. I have to begin with it. Xi are the various observation. What are my observation here? So in the first part, these are first natural number, so 1, 2, 3 are xi's. In the second part of the question, they are 2, 4, 6. Are you getting the idea? Perfect. Okay, so this is the case. So I have to first of all go for sigma xi square by n, the first term, right? The first term. So sigma xi square by n is nothing but what? Individual observation is 1, 2, 3, first and natural number. So their squares are what? 1 square, 2 square, 3 square. So I want the average of them. 1 square plus 2 square plus 3 square, so on till n square, divide by n, the total number of observation. Right? So up to n term, what is the sigma n square in the numerator? So this numerator is sigma n square by n. Sigma n square formula from the sequence and series, you remember, that is n by 6, n plus 1 into 2n plus 1 divide by n. So this n got cancelled. I'm left with n plus 1 into 2n plus 1 by 6. Perfect. Okay, that's what it is. Let's go for the second part, which is the sigma xi by n. What is sigma xi by n? Average of first and natural numbers. What is the average of first and natural numbers? That is nothing but sigma n by n. See, numerator is what? Sum of all the natural numbers. That is sigma n. What is sigma n? That is n by 2 into n plus 1 whole divided by number of terms, which is n. So n got cancelled. We got this quantity as nothing but n plus 1 by 2. Okay. So if I have sigma xi square by n, if I have sigma xi by n, let's plug in the value. So delta square was nothing but sigma xi square by n minus sigma xi by n the whole square. So the moment when I plug in the value here, what do I get? Let's quickly put the values. So the first one is nothing but n plus 1 into 2n plus 1 by 6 minus of n plus 1 by 2 the whole square. Okay. So this is the case. Let's quickly simplify it. I need to simplify that, right? Otherwise, I won't be able to move ahead of it. Okay. So from here, delta square become is equal to, I'll be taking that n plus 1 by 2 common from both of them. I'll get this 2n plus 1 by 3 minus n plus 1 by 2. Very simple simplification. Take that LCM and simplify. You get this as n plus 1 by 2 into n minus 1 by 6, which makes it as n square minus 1 by 12. Everyone understood this calculation? See, I want all of you to note it down this one. So this is n square minus 1 by 12. This is what my delta square for the first n natural numbers, right? And this variance is given to me as 10. All right, understood this? Sure? Perfect. So this n square minus 1 by 12 is given to me as 10. Okay. Everyone, please note down the calculation. I'm giving you some time. Please copy it very carefully. The formulas, the results, and every single thing which I'm explaining here. Take your time. Note it down properly, right? Just quickly see where exactly you're getting stuck. So refer to that one also. So please take your time, note it down properly, and see everything carefully, right? Note it down. Everyone. Okay. So all of you copied it. Perfect. Formula. Sigma xi square by n, how did we calculated that? Sigma xi by n, how do we calculate? Then how do we do the simplification for delta square value? That is sigma xi square by n minus sigma xi by n the whole square. Then I plugged in the values, simplified, taken the LCM, we got n square minus 1 by 12. Okay, now I'm erasing this much part, like some things here. Okay, so delta square, effectively I got n square minus 1 by 12. Okay, let me just quickly erase this so that I can write it a bit neatly. So I can say that my so far delta square has become n square minus 1 by 12. Now I know that this delta square is given to me as 10, which implies that n square minus 1 by 12 is given to me as 10, which implies that n square minus 1 is given to me as 120, which implies that n square is given as 121, which implies that n is nothing but equal to 11, not plus minus 11. Why? Because natural numbers, right? N is what? First n natural numbers. This has to be what? Natural number only. So n equal to 11. Wow, a lot of calculation, but I finally reached to the value of n as 11. Sorted, everyone. This is the final calculation that we have reached to, in case if you want to note it down. So we got n equal to 11. Sorted. Let's try to find out the variance for the second case. That is the first m even natural numbers. So now I have the even natural numbers, right? So if I have the even natural numbers, I have to make sure that the numbers and the variance has been taken care very well. How will I be doing that? Variance of 2, 4, 6 is equal to 4 times of variance of 1, 2, 3, 4. How's that possible? How's that possible? Is it really true? Just remember, what do we have it here? The formula was sigma xi square by n minus sigma xi by n the whole square. Now, earlier the observations were 1, 2, 3, 4. Now they are 2, 4, 6, 8. That is exactly every observation got doubled, right? So something which was xi earlier, now in the modified format, they are 2xi whole square by n minus sigma 2xi by n the whole square. If I take the 2 common from that, so out of square, they will become what? 4 times of sigma xi square by n. Again, I can take that 2 common out of the sigma. So 4 sigma xi by n the whole square. What is that? That is nothing but 4 times of delta square that we have just defined in the previous case, right? This is nothing but what? 4 times of delta square. And that is why we were saying that variance of 2, 4, 6 is nothing but equal to 4 times the variance of 1, 2, 3, 4. Are we getting the point, right? Okay, so can I generalize it? I'm giving you a formula, right? I'm erasing this calculation and I'm giving you a simple observation over here, which will generalize you so that if you get something of that sort in the examination, you will be able to do it very quickly. Okay, what is that? If you have, let's say, the variance of a variable xi, or let's say if I write delta xi is equal to some k, then rather delta square of xi is equal to k, then delta square of lambda xi will be lambda square k. See, earlier my observation was 1, 2, 3. Now my observation is what? My observation is 2, 4, 6. Every element got double, right? So 2 square came out. So had it been 3, 6, 9, it would have been 3 square times of original delta square. That's what it is. right? So if delta square of xi variable is k, then delta square of lambda xi is lambda square k. For example, here, if I'll be taking it for simply 1, 2, 3, that was simply, let's say, some k, then for delta square, for 2, 4, 6, that is nothing but, that is the multiple of 2 times of that, right? So it is 2 times of 1, comma 2 times of 2. So that has to be what? 2 square times of k, right? Or 4 times of that variance. Are you getting my point, everyone? Okay. So the idea says that if the variable is lambda times, then its variance will be lambda square times of the original one, right? If you make any variable lambda times, then its variance will become lambda square times of that one, that's original variance. Understood? Sure. Shall we move ahead? Perfect. So in general, I'll say that delta square for lambda xi is equal to lambda square times of delta square of xi, right? Okay. So that's why here 2 is as a multiple. So this 2 has become eventually as 2 square for the calculation purpose. So this 2 square is finally 4. Now let's plug in the values quickly. So what was the variance of 1, 2, 3, 4 in terms of n? That was n square minus 1 by 12. So here I have m natural numbers. So in terms of m, this will become equal to 4 times of m square minus 1 by 12, right? So in terms of n, it was what? N square minus 1 by 12. So in terms of m, it will become m square minus 1 by 12. Perfect? Okay. So this will also get cancelled. It will become 3. And this value is given to me as 16 in the question. That the if I take up the first m even natural numbers, then it becomes equal to what? 16. Okay, perfect. Let me do the calculation quickly. So we have this m square minus 1 by 3 equal to 16, which implies that m square minus 1 becomes equal to 48, which implies that m square becomes equal to 49, which implies that the value of m becomes equal to what? 7. So the moment when I get the value for m as 7, the value of n was 11. Okay, so we got m as 7, we got n as 11, which implies that m plus n will become equal to 11 plus 7, which is nothing but what? 18. So my answer becomes 18. So in fill in the blanks, you have to type 18. People understood this? How we are moving ahead with it? Everyone? So there were many insights in this question. So first one was the formula for variance itself, that is sigma xi square by n minus sigma xi by n the whole square. And then if the variance of xi variable is some k, then variance of lambda xi will be lambda square k. That's it. Perfect? Sure? Now this question is a very popular application. Can you connect it to the chapter? Sum of the coefficients of even powers of x in the product. Where have you seen such questions? Which chapter? Which chapter? Sum of the coefficient of all even powers of x. Binomial theorem. Exactly. All right. Okay. So generalized is the generalized format of that one only. Now let's quickly begin with this. So they say that sum of the coefficient of all even powers of x. So there is a product. So even if I simplify the product, I'll get some powers of x, right? Some even powers of x, some odd powers of x. They are saying that I want the sum of all the even powers of x in the product. Okay. And that turn out to be sum of all the even powers of the x, or rather sum of the coefficients of even powers of the x is 61. Then they're asking the value of n. So first of all, I'll consider this product. Whatever this product is, it has to have some powers of x in, right? So I could write it as, like, let's say a naught x raised to 0, which is 1. So a naught plus a1x plus a2x square plus a3x cube and so on, right? So I'm assuming expansion to be somewhat like this. It doesn't matter whatever the coefficients are, right? What is a2, a naught, a1, a2, a3 is there, doesn't matter. Because I am interested in the sum of all the even powers. Okay, so let's keep that in mind. And do you remember how do we get the sum of all the even powers? Just remember that logic. Logic was you put x equal to 1 in this one, then you put x equal to minus 1, and then you add both of them. What will happen? When you put x equal to 1, all the coefficient got added. When you put x equal to minus 1, you got a naught minus a1 plus a2 minus a3. So all the odd ones are with the minus sign. And when you add them, eventually all the odd coefficients will get cancelled. You'll be left with only the sum of even powers only. That's the trick that you have to remember and utilize every time now in the future you are getting such question. All right, let me begin with the calculation. So I'll be quickly putting x equal to 1. The moment when I put x equal to 1, what do I got? I got, see, LHS is what? It will give me 1 plus 1 plus 1 how many times? So this one gives me 1 plus 1 plus 1 what? How many times? 2n plus 1 times. Right? The other bracket is simply 1. Because the other things will get cancelled, it will become eventually as 1. So that is equal to what? A0 plus A1 plus A2 plus A3 and so on. Okay. Now, what if I put n equal to x equal to minus 1? Okay, so I'm removing this 2 and 1. So once again, when I put x equal to minus 1, see, the first one will give me what? The first bracket will give me 1 now. And the second one will give me actually 1 plus 1 plus 1, 2n plus 1 times. Because when I put x equal to minus 1, the second bracket here, right, every term will become positive only, because minus x will become minus of minus 1 as plus 1. So we get 1 plus 1 plus 1 how many times? 2n plus 1 number of times. Perfect. See, every bracket has 2n plus 1 terms, right? This is also 2n plus 1 terms. This is also 2n plus 1 terms. So when I put x equal to 1, the first bracket becomes 2n plus 1, second becomes 1. And when I put x equal to minus 1, the second bracket becomes 2n plus 1 and the first one becomes 1. And what do I get? We get a0 minus a1 plus a2 minus a3 and so on. What will I do? I'll be actually adding up these two equations. So if I call it this, let's say equation number 1, I call this as, let's say, equation number 2. So add equation 1 and equation 2. What do I got on the LHS? I got 2n plus 1 plus 2n plus 1, that is 2 times of 2n plus 1. What do I got on the right side? So I'll be getting LHS as 2 times of 2n plus 1, and on the right side I will be getting 2 times of a0 plus a2 plus a4 and so on, which is nothing but sum of the coefficients of all the even powers of x. So this 2 got cancelled, right? So sum of coefficient of all the even powers turns out to be 2n plus 1. So this sum eventually is given to me as 61, which implies that 2n plus 1 in this question is given by 61. Take that one on that side. What do I got? I got 2n is equal to 61 minus 1, which is 60, which implies that n becomes equal to what? 30. Understood, guys? So answer is 30. That's a different thing. Logic is, if you want to reach to the sum of all the even powers, rather coefficient of even powers, you want to reach to the sum of coefficient of all the even powers of x in this product or in this type of products, whatever the expansion is, you have to put x equal to 1, you have to put x equal to minus 1, then you have to add both of them in order such that you are finally left with only the even power coefficients only, right? So the moment when you add them, you can clearly see when you add these two equations, these two, right? So when you add these two equations here, you'll be left with nothing but as the right side as 2 times of a0 plus a2. Minus a1 plus a1 will get cancelled. Minus a3 plus a3 will get cancelled. So you'll be left with only the sum of coefficient of all the even powers of x. Sorted? What a lovely question. The question says that let S be the set of points where the function, so there is an expression given fx is equal to mod of 2 minus mod of x minus 3 whole mod. X belongs to R is not differentiable. So capital S is the set which contains the instances or the points where this graph of fx is non-differentiable, or basically is having sharp turns, right? Because if a function is non-differentiable, we say that this will be having sharp turns in terms of graphs. Keep that in mind, okay? So number of non-differentiability points, sharp turns. Perfect. Then the value of sigma x belongs to capital S, whatever the elements in that set S will be. I want to have the value of f of x at those non-differentiable points. Understood the question? Let me explain it more. To begin with, I have to first of all deal with the graph of fx is equal to mod of 2 minus mod of x minus 3. So just for my understanding sake, I'm just also writing it as mod of x minus 3 minus 2. See, if I take a minus sign common out of the mod, it doesn't make any difference. Now, understand why am I doing this? I'll be actually plotting this graph for you. And how will I be doing that? First of all, I'll plot mod x, then I'll be reaching to mod of x minus 3, then I'll be reaching to mod of x minus 3 minus 2, then I'll be reaching to mod of x minus 3 mod minus 2. This. The whole mod of mod x minus 3 minus 2. Right? This is a method of working will be my method of working in which I want to move ahead. All right, let's quickly move on. So mod x is simply this graph. Very simple. X, y, 0. Then from here I'm reaching to mod of x minus 3. So my critical point will become what? X equal to 3. So my graph becomes somewhat like this, this. So this is 3, right? And this becomes what? Also 3. Perfect. Okay, so we got this as mod of graph of mod of x minus 3. Perfect. From here, I'm reaching to mod of x minus 3 minus 2. So I have to pull this graph by 2 units downwards, right? See, mod x, from mod x to mod x minus 3, I just shifted the graph by 3 units on the right side. Simple transformation, right transformation. Then mod of x minus 3 minus 2, the whole graph has to be pulled down by 2 units, right? So I'll be pulling this graph. So the entire graph, this entire graph will be pulling down by 2 units. Okay. So let's quickly pull it out. So the value which was at 3, now it will reach at 1. Okay. And the instant point was 3 only. So at 3, it will reach to what? It will reach to minus 2. So this is the graph that I'll be behaving with. So this is 1, it's minus 2, and like this. Right, so this value reaches to minus 2 at 3, and this value is 1 now, because the value of 3 has been pulled out by 2 units downwards. So the value 3 reaches to 1, and the value which was at 0 has reached to minus 2. Perfect. Okay, now the last one. You have to take the modulus of the entire one, right? So whatever the graph which I am able to see below the x-axis, I'll just reflect it above the x-axis. So my graph finally will look somewhat like this. It will be this. So this instance where it is actually cutting the x-axis, that will be the point where it becomes this expression mod of x minus 3 minus 2 becomes equal to 0. That is clearly when you put x equal to 1, right? So this instance turned out to be nothing but x equal to 1. It's a simple observation which you can understand. So at this instance it will go like this, then again at 3 it will go up, then again at 5 it will go down, and like this. So this is 0, 1, 3, 5. Please don't go after the distribution or the scale of the graph. I hope the understanding is clear. So we started with mod x, then we moved to mod of x minus 3, then we moved to mod of x minus 3 minus 2, then we taken up the mod of entire graph, that is the portion below the x-axis have reached to the above the x-axis, and all the points I have marked. All right, so this value is also 1. So f of 0 becomes 1. At 1, 3, and 5, we are having the sharp turn. So my final graph looks somewhat like this. Everyone, please be comfortable, understand this, because these are very simple transformation. You must have done them earlier before. It's just that you have to set up your mind in that way. So my graph finally becomes somewhat like this. So that's why a neat and beautiful graph is also there so that you can copy it quickly. You can clearly see f0 is 1. So the value of f of 0 is 1 here. Then the value at 3 is nothing but 2. So this f of 3 is nothing but 2. F of 0 is nothing but 1. And simply f of 5 is nothing but 0. So f of 5 is nothing but 0. This is what the situation that we are facing here. Perfect. So f of 5 becomes 0, f of 3 becomes 2, and here f of 1 becomes also 0. So f of 1 is also 0. And here at 0, I can say that f of 0 equal to 1. So these are the 4 points which I marked. F of 0 is 1 here, f of 1 is 0, f of 3 is 2, and f of 5 is 0. Everyone comfortable with it? Sure? Plotted the graph. First mod x, then right transformation, mod x minus 3, then pulled it by 2 units downwards, mod x minus 3 minus 2, then reflect the entire graph in order to operate the mod, because mod, what mod does? Mod actually create every graph. It makes everything positive, whichever is negative. So whatever the portion which was lying below the x-axis, which is negative, it has made up equally positive. So we just reflect the portion of the graph below the x-axis as mirror. Sorted? Okay, so we got these situations. Okay, now I'm moving on with the calculation part. So my graph is ready with me. Perfect. I'm happy that I have my graph. And the observations are also clear. That is f of 0 equal to 1, f of 1 equal to 0, f of 3 equal to 2, and f of 5 equal to 0. Now, my question said that I have to look for the non-differentiability point. At how many points the graph is having a sharp turn? It is having a sharp turn at x equal to 1, x equal to 3, and x equal to 5. 3 points of non-differentiability. So I can say that the 3 points of non-differentiability are nothing but 1, 3, and 5. So basically my set S is nothing but containing the elements 1, 3, 5. Understood? Perfect. Okay, now what do I have to do? I have to go for the question. The question language says I'm looking for the sigma. Condition for x is that x belongs to capital S, f of x. Okay. So I have to take in the sigma for those values of set in S, which are nothing but 1, 3, 5, and I have to find the value of f of x at that time. That is, I will be looking for sigma x belonging to what? 1, 3, 5 at rather the like at 1, 3, 5 the value of the expression f of x. Is there a clarity what we are doing here? So when I put x equal to 1 in the bracket, what do I get? I get f of 1 plus then the next value f of 3 plus the next value f of 5. Are you able to understand this? Please be comfortable about it. There are 3 points of non-differentiability, which are 1, 3, and 5. And I have to find the sigma of the values at 1, 3, and 5 for f of x. So at x equal to 1, this is f of 1, sigma, so plus. The next value is f of 3, sigma, so plus f of 5. Sorted? Perfect. Now guys, I have on the right side, I've written all these standard values. So what is f of 1 do we have? 0. Okay, so what are f of 1 is? So this becomes f of 0 because f of 1 is 0. Okay, f of 1 is 0. Then the next value is, this is simply, okay, let me write it precisely, right? So this value is 0. F of 3 is 2 and f of 5 is 0. So what do I have? This becomes equal to f of 0 plus f of 2 plus f of 0. Okay. F of 0 also I have pointed out. I just need to check f of 2. So what is f of 2? This is nothing but equal to 1. So f of 2 turns out to be 1. You can also put it by just plugging in the value. Check for f of 2. See, if I take up the definition, so definition for fx was mod of 2 minus mod of x minus 3. So if I put f of 2, that will be mod of 2 minus mod 2 minus 3. What is mod 2 minus 3? Mod of minus 1. Mod of minus 1 is 1. So what have I got it here? We get this mod of 2 minus 1 or simply 1. So f of 2 turns out to be 1. Is that okay? And graphically also you can see that f of 2 turns out to be 1, which is a much simpler observation. Okay, so f0 is already 1. F of 2 also turned out to be 1. What does that mean? This becomes 1 plus 1 plus 1. So 1 plus 1 plus 1 will give me the answer as what? 3. So finally the answer to this question is 3. A very simple digit that you type and you get the answer. It's a single digit answer. Question is really interesting. First of all, you have to understand how we are plotting the graph of mod of 2 minus mod of x minus 3. For that, we have used the transformation path, which was mod x, then mod of x minus 3, then mod of x minus 3 minus 2. We pulled the graph by 2 units down. Then we have applied the mod on the entire graph. That is, the negative portion of the graph has been reflected with respect to x-axis as a mirror. Once this is sorted, we found the value for f of 0, f of 1, f of 2, f of 3, f of 5. Okay, you can also do it not just by graph, just by directly plugging in the value in the original expression, you can also get the value, right? That is also a way, but the graph is really simple. They are straightforward straight lines, so not much of a difference. Okay, now, so my set S contained 3 elements, 1, 3, and 5. They wanted to have the value of f of x for 1, 3, and 5. That is f of 1 plus f of 3 plus f of 5. But f of 1 was 0, f of 3 was 2, and f of 5 was 0. So we eventually lead to f of 0 plus f of 2 plus f of 0. F of 0 is 1, f of 2 is 1, f of 0 is 1. So we got 1 plus 1 plus 1. The answer simply becomes 3. Many good takeaways for this question. The transformation of the graph, understanding the sigma, how we are behaving with it, and then computing the values. The point of non-differentiability are equal to the sharp turns involved in the graph. There are only 3 sharp turns, 1, 3, and 5. So I have 3 non-differentiable points. Understood it? So for all such questions, the question was very, very simple. It was nothing difficult. It's just that you have to predict the language very carefully and then find out the answers. So it was a very simple question, but of course, a smart question. All right? Now, this question is very, very simple, but a very nice insight is to be used. And a property, a very common property that you have studied in geometry. This is something that you have to use here. The question might look a bit different if you don't remember the property. So that's why we say that whatever the results of geometry that we have taught you, you have to remember them very well. and keep revising it again and again so that this becomes your strength. Okay, now let's quickly move on. So it says that there are 3 points A, B, and C. These are the vertices of a triangle ABC. Let's say these are the vertices of the triangle ABC. So that's what my vertex of the triangle ABC. P is a random point inside such that the triangles have equal area. So somewhere the point P is such that the area of these 3 triangles, this triangle, and this triangle, they're all same. Where have you studied this? That the area of such triangles will become equal. If this is A0, this is also A0, this is also A0. Where have you studied that? What kind of this point P is there? Do you remember? Centroid is the point which, when you join it from the vertices, the 3 triangles formed will be always of equal areas. This is the key takeaway for this question. The moment you do it, the calculation is the simplest one. Within 10 or 20 seconds, you will be able to finish this question. Trust me, the calculation is really, really simple. The only fact is that if somebody says that in a triangle ABC, if area of triangle PAB equal to area of triangle PAC is equal to area of triangle PBC, that can happen only if P is centroid. So P has to be the centroid here. All the 3 vertices are known to you. You know the formula for centroid: x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So if you would not have been able to solve this question just because of this fact that you did not know this, that if the area of triangle PAB equal to area of triangle PAC equal to area of triangle PBC, that happens only when the point P is centroid. Or in other words, if you join the centroid from the vertices, the 3 triangles formed will be of equal areas, always. Alright, so you've understood it now. Please try this question quickly. Try to report the answer before me. Alright, I'm anyhow solving it. So one thing is pretty sure, that P is the centroid. Now if P is the centroid, that has to be nothing but the x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Okay, so I'm just keeping it here. So in a triangle ABC, I'm writing it here so that my bracket can be larger. Because of that reason only I'm doing it. So x1 is 1 plus 6 plus 3 by 2 by 3, comma y1 plus y2 plus y3 by 3, that is 0 plus 2 plus 6 by 3. So what is 1 plus 6? 7. 7 plus 3 by 2 is 17 by 2. 17 by 3 by 2 by 3 is nothing but what? 17 by 6. And similarly, 6 plus 2 is 8. 8 by 3 is simply 8 by 3. So we got the centroid as, so this is what my centroid is. 17 by 6, comma 8 by 3. Now they are saying that find the distance between PQ. Point Q is given to me as minus 7 by 6, comma minus 1 by 3. What do you have to do? Distance formula, guys. Do it quickly. So PQ is nothing but simply the distance formula between these 2 points. And if I try to figure it out, what do I have it here? We have x2 minus of minus x1. So basically x2 minus x1 whole square, not x2 minus of minus x1. I was reading in that language. So x2 minus x1 whole square. So we get this, plus y2 minus y1 whole square. So we get y2 minus y1 whole square as this. Let's simplify. What do I have it here? This is 17 plus 7 by 6, that is 24 by 6 the whole square, plus 8 plus 1, that is 9 by 3 the whole square. What is 24 by 6 whole square? So 24 by 6 is nothing but 4 square. And 9 by 3 is nothing but 3, so we get 3 square. What is root 4 square plus 3 square? So root 4 square is nothing but 16. 3 square is 9. Root 16 plus 9 is root 25. That turns out to be what? 5. What is my answer? Simply 5. Alright, so we get this as simply nothing but root 16 plus 9 equal to 5. Understood it? Everyone got the idea how we are actually moving ahead with the calculation? Key takeaway for the question was that if P happens to be the point which is inside the triangle such that the triangle formed by joining the vertices of the triangle, so rather the 3 triangles formed by joining the vertices with this point P such that they are of equal area, then the point has to be centroid. Right? Or centroid, if we join the centroid from the vertices, then the 3 triangles formed are always of equal area. Understood? So area of triangle PAB equal to area of triangle PAC equal to area of triangle PBC. Understood it? Alright, perfect. So I hope the entire theory is clear to everyone, right? So just for the revision sake, this area is equal to this and all the three are same. Then P has to be the centroid. All right, everyone, lovely. So we got the answer, the numerical digit answer as 5. So with this, we end the discussion of this paper. The paper was JEE Main January 2020 morning batch. Now, there are many insights. A lot of in-depth analysis has been done. In every question, I've given you the key takeaway and what you should be thinking. How shall you be thinking about it? Of course, there are some facts which you have to remember. If you will not be able to recall it, then of course, it will be difficult for you to solve those questions. So in that case, I will always suggest you revise as much as you can before you are actually attempting the paper. And I'm sure if you are referring to these solutions, you must have practiced them once at least, right? So try them, then only refer to all the solutions. All right. So keep the speed, keep the accuracy intact. And the keyword in the mains is that you have to be, of course, the accurate as well as fast, but you have to remember a lot of results, because when you apply them directly into the examination hall, it will save your time. I'm not saying that you cannot derive them. Of course you can. But if you know the formula directly, you plug in the values, it will definitely save your time. And that time which you have saved there, you might utilize it into any other tougher questions. All right. And you must have also seen that there were some freebies, right? In every paper, there are always some freebies. Try to figure out the questions which are really simple, which are based upon only one concept. Make sure you're not at all going to make any mistakes in that, because that will build upon your foundation score. And once you have solved all those questions which were easy to you, which you were knowing beforehand and you were able to solve it, then the ones which you will be able to crack in the examination hall, the difficult ones, that will actually increase your rank. All right. So with this, I wish you all the best for your preparation. And then if you want to refer to more solution, if you want to study more for these concepts and their in-depth or discussion of these concepts, please refer to the BYJU'S videos and the BYJU'S classes program. So with this, I, Keshav, will be saying a goodbye. I want all of you to take a very good care of yourself. Be very, very punctual in your routine and highly disciplined and organized. The success will be yours. All of you will be coming out with the flying colors. Goodbye and take care.